The next big topic we're going to look at is similar triangles, and the two triangles we have down here below are similar. And what makes two triangles similar is that they have to have the same angles within them. So if we were to look at this angle here, I'm going to use a label for it. I'm going to call it angle CAB, right? So that would be CAB, this angle right here. That angle is equal to the angle over in the larger triangle on the right, angle FDE. So that would be equal to angle FDE. And we could do that with all three of the angles that are in each triangle. So we could also say angle ABC is equal to angle DEF. And finally, we could say angle ACB is equal to angle DFE. And since those three angles, corresponding angles, right, this angle here corresponds to this angle here, and this angle here corresponds to this angle here, and this angle here corresponds to this angle here. Since those three corresponding angles are equal, then that tells us that these two triangles are similar. Essentially, it's one triangle is a shrunken or enlarged version of the other triangle. That's what makes up a similar triangle. And this definition that I've got written up here is a little wordy, so we're going to look at that in the context of an example here shortly. So now that we have a definition of what similar triangles are, it's going to allow us to do some things with these triangles that we normally wouldn't be able to do with any old triangle. So we have two similar triangles down here below. You can hopefully see that the one on the left is a little bit larger than the one on the right. And in this example, in the question, we're being told that the two triangles are similar, just in case you weren't sure of it. They're telling us that they are similar. And we want to know, in this question, the length of side WU. So that would be this side over here that we're wanting to know. Now let's go back up to that definition I had. Two triangles are similar if corresponding angles are equal. So that we already dealt with. But this second part, the ratio of corresponding sides are equal. That's what we're going to be able to use to solve for this missing side over here. And so let's break down what that means. Ratio, we've dealt with them before. The ratios are just kind of like fractions, right? And corresponding sides. Okay, so corresponding sides are similar to what we said about corresponding angles. So this side, XZ, corresponds with this side, WU. And we can say the same thing about XY, corresponds to WV, and YZ corresponds to VU. And so those are our corresponding sides, and we can write that out in an equation, kind of, saying side XZ divided by, right, that's XZ right here, divided by side WU, the corresponding side in the other triangle, is equal to side YZ divided by side VU, because those are corresponding, YZ divided by VU, and that's also equal to side XY divided by side WV, because those two are corresponding, so side XY divided by side WV. Now that last piece of information we're actually not going to use in this question, right? Because we don't know anything about this, we don't know anything about this. There's two unknowns that we're not even interested in knowing what they are, so that piece of information is not going to come into play here. We know a lot of things about these two ratios, so we're really going to focus on those. So let's start filling them in. What is side XZ? Well, it's 7.9. So we'll write that in for side XZ. What is side WU? Well, that's what we don't know. That's what we're being asked to solve for, so we'll just leave that as WU. And this can be treated, this WU can be treated just like an X, like a variable that we've dealt with before. Now let's move on. Side YZ is this side right here. So it's 4.5. and side VU, that's over here, that's 3.1. So now we've got what we would call, in math terms, we'd call that a proportion, right? And in order to solve for WU, the kind of shortcut I show people often is you take the two numbers that are across from each other and you multiply them. So on your calculator, you'll say 7.9 times 3.1. And then the number that's across from your variable or your unknown, i.e. this 4.5, you're going to divide by that number. So you're going to say 7.9 times 3.1 divided by 4.5. And that's going to give you, I'll write it over here, side WU, and side WU, if you run that in your calculator, is going to give you 5.4. And we have units in here, right? We have meters in each of these, so we might as well include our units of meters. Now these are very often, these triangles are not drawn to scale, meaning that you know, this doesn't necessarily have to be 7.9 and this doesn't actually have to be 4.5 meters, but you should still be able to look at these when you get your final answer and look at putting that in there and saying, does that make sense? Well, this side, if it's 3.1, well, this side over here, WU, looks a little bit longer. So 5.4 does seem like a pretty reasonable answer. Look over at your other triangle, your large triangle over here. Does 5.4 kind of jive with this side? Well, this side's 7.9, so, and this side is definitely shorter than it, so it should be a little bit shorter than 7.9, which it is, it's 5.4. So just to kind of do a little check with your similar triangles when you get your answer is always nice. So that's what similar triangles are. That's how we can use them to find unknown sides, and we'll look at a couple more examples in the next video.